Okay, lesson 3, applied. Unit 1 is compound interest, the future value. And so lesson 2, we talked about compound interest, but it was only if it was compounded per year. And this time we could compound it more than once in a year. Okay, so the formula is A, which is the final amount, is the principal amount times, in brackets, 1 plus the interest rate as a decimal divided by the number of compounds per year to the exponent of n times t. Okay, so if you, for instance, compounded something monthly for 2 years, then you would have 24 there. So you would have 12 and 24. So that'd be an example. Okay, in this lesson you'll also use the rule of 72. It's just an approximation of how long it would take to double your investment. You would do 72 divided by the interest, and this would just be the rate, not as a decimal. And again, it's just an estimate, not an exact. Okay, so number 1 here. How many compounding periods are there for $100,000 invested for 8 years at 4.8% compounded monthly? So this just asks for compounding periods. So if we, for 8 years, compounded something monthly, then you would end up with 96 compounds. That's all that's asking. You know what, I'm going to do number 11 first and then come back to number 10. Okay, a local business invests $400,000 and then their interest rate is 4.2. How much interest is available for this trust fund each year? So time is just 1 year. Okay, and we also need the compounded quarterly. Okay, so we're going to go, the final amount is the principal, 1 plus the interest rate divided by the number of compounds. And this would be, we'd only end up with 4 compounds because 4 times 1. Okay, so in my calculator, I can do this all in one step. 400,000 times bracket 1 plus 0.042 divided by 4 to the 4th. And I get 417,066.46. Okay, but that's not my answer. That's what the fund would be worth. So I would subtract off the principal. Okay, so subtracting off the principal, you get $17,066.46 of interest. Okay, it's kind of like opposite of simple interest where we found the interest and then we'd had to add if we wanted the final. This time we get the final and then we would have to subtract if we want the interest. Okay, back to number 10. Motorcycle. That's what she has, and that's only half of what she needs. So the final would be 14,000, right? And the principal is 7,000. Okay, she's investing. We have that as a rate, compounded monthly, so n equals 12. So we want to know the time. Okay. So this is a tricky one to show you, so I left it till after, but we can do an estimate first, actually. 72 divided by the interest rate, not as a decimal. So about 13, so that's our estimate. Okay, so let's see what we can come up with. Okay, so final amount equals the principal times 1 plus 0.53 divided by 12 to the 12t, because that's what I don't know. Okay, I am going to divide by 7,000 on both sides. So I get 2 equals, and then I'm just going to write this all as is. Okay, now I'm going to go to my graphing calculator. I'm going to put this into y1 and this into y2, and I'm going to see where the intersection is. So how do we do that? Okay, so y equals button. Okay, so into y1 I'm going to put 2, and in y2 I'm going to put brackets 1 plus 0.053 divided by 12 to the, and then I'm going to actually put this in brackets as well, as the exponent 5x. Okay, so since I know my estimate was 13-ish, I'm just going to make sure, I'm going to go to like 20 just to see, and my y is only at a 2 where I want it to be, so we don't need that much. Okay, so here's my 2 line, here's the other one. Your investment is increasing, increasing, increasing. Okay, so what I'm going to do is hit second function trace to calculate. I'm going to go down to intersection. First curve, it says, I enter. It jumped to my second curve, enter, guess, enter. 13.11. So that's the actual, but it says to the nearest year, so 13 years. Okay, and number 12, we're going to consider these rates, rank the rates from greatest to least return on investment. Okay, A. So we're going to start with 8,000, 1 plus 0.054 divided by, so if you compound something annually, you're going to only do it once a year, and that exponent would be 5. So 8,000, whoop, too much, times 1 plus 0.045, I don't need to divide by 1, to the 5. Okay, I'm going to take 8,000 off of that so that I know how much interest I made. Alright, now B. So we're going to go 8,000 was our principal. 1 plus 0.0535 divided by, we do quarterly, and so our exponent is 4 times a year times 5 years, or you could say 20. Okay, so 8,000 times 1 plus 0.0535 divided by 4 to the 20. 10,435.03, and again I'm going to take 8,000 off that if I want to know the interest. And C, so again 8,000 and 1 plus 0.052 divided by monthlies, so that's 12, and then if we do 12 every year for 5 years, or you could write 60 there, so 8,000, 1 plus 0.052 divided by 12 to the 60. So I'm going to take 8,000 off. So those are all of my interest amounts. So return on investment, you're going to take them and divide by 8,000. So 2406.22 divided by 8,000. So this is a 30.08% return. And divide by 8,000. This one is a 30.44% return. And this one divided by 8,000 is a 29.62%. So if you're ranking them from least, C is the least return, and then A, and then B is your biggest return on investment.